recap where we were. We were looking at this question. It was part of our sequences stuff. So we were trying to look at, is it an arithmetic, is it geometric? So I was going through it saying, right, there are two types of interest. Simple interest is just an arithmetic, just adds the same on every time. And compound interest, which is this one, is a geometric. So I was going through why that is. So if it's 10% per year, simple interest, every year we just add 10%, which if I make it 100 to keep it simple, 10% is $10, right? So every year we just add 10. But compound interest, do you remember it was like, well, after the first year it's 10% is still 10, it's the same. But the second year, it's now 10% of 110 rather than another 10, so we had 11 and so on. And then I was saying, right, we went through how do you add 10% on to something? And in this case, I said, well, here's a different example, increase 70 by 6%. And I asked you how to do that. The first method, which is the normal, is to say, work out what 1% is, times it by 6, works out what 6% is, add it on, and you get the increase. Yeah. But I did say, well, there is a more efficient, effective way, right? So we could, instead of finding 1%, we could just get 6% straight away, multiplying by 0.06. But I still have to add it on. But if I do 1.06, that does the adding on straight away. Make sense? So what I then said was, if I do 70 times 1.06, that bit there, right, just that calculation will tell me the amount after year 1. Yeah? If I times it again, that would be the amount after year 2. So if I did 70 and then I did times 1.06, I get the answer of 74.2. If I times by 1.06 again, I get the answer 78.652. If I times by 1.06 again, I get, did you do it, did you? Can you do it? Can you do 78.652 times 1.06 for me on your calculators? Whenever I say do it on your calculator, you want the wall to do it because you have this. Like you text on your phone, the quicker you get. 83 point. Okay. If I then multiply by 1.06 again, point. No, just give me 2 and round it correctly. Okay. So, do you see how if we do multiply, 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 what kind of sequence are we creating? Multiply is a geometric sequence. Yeah? So if we go back up to this problem, okay, let's use the numbers here. So it does say some money is invested which pays compound interest annually. I've got some more questions, so hopefully we'll understand a bit more about that. At the end of 20 years, the account is worth that much. At the end of 21 years, it is worth that much. Find the amount of money at the end of the 30. Okay, so like we've done before, let's set up our list. So we could start with 1, 2, 3, all the way up to 20. I know 20 is 29,136.22. Okay? And then 21 is 29,718 point. Yeah. Now I've got to work out how it is in the 30th year. So, what do we need to do? Find the what? It's not a difference. It's not that, is it? Why not? Because we know it's a geometric. Yeah? How do I know it's geometric? Yeah, good. So compound, this is one of those questions where it doesn't tell you it's geometric or arithmetic, it tells you it's compound interest. You have to know that we are timesing by a percentage rate. Right? That's the knowledge you have to have. If it said simple interest, you know it would be a arithmetic, yeah, plus D. Because it says compound, we know it's geometric. That's the only piece of information that tells me that. That's all I need. Okay, so what are we finding? Not the difference, but the times the R, which is called the ratio. So we want to know what the ratio is. How do we work that out? No. Okay. So 29,718.95 divided by 29,136.22. Okay. And you get the answer? $1.02. Okay, so we'll stop there. Do you know how to interpret that? So what's the interest rate? It's not. It's actually, well, it's an increase. So that is 102%, which means the interest rate is 2%. Remember, doing the 102 is an increase of 2. So it's 2. But we don't actually need to do that. We just need to now get to the 30th. How do we do that? Yeah. How many times? So we're going to do 29,718.95 times 1.02. So 21 to 22 would be 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. Okay, how do I do times something 9 times? So like times 1.02, times 1.02, times 1.02, all the way up. I could do that more efficiently, do you remember? Yes, it is. So we're going to do, 29,718.95 times 1.02 to the power of 9. Makes it nice and quick and easy. So you can do that on your calculator. Did you? Can I just check on your calculator that you did it? You read that out to me? You read? 355. 6. I think there's more numbers there, isn't there? Should be. 355 16 point. So we 62. So let's round that to 35516.90. Okay. Does that make sense? So it's 35,000 when it was at 29,000. So the answer seems to make sense. The other two, did you confirm that you get the same answer? Yeah. Which is less, which makes sense that banks would use compound interest, right? How do you feel about that compound interest sequence stuff? Yeah. Let's just think, what did I want to do next? Let me look at this one. All right, so we've got another one, another sequence, but what I thought we would do, I've got some more compound interest questions for you to do on that page. Okay. So let's do this first one together and then you can work through some others yourself. Okay, so Toby invested £4,500 or dollars, whatever, for 2 years in a savings account. He was paid 4% per annum compound interest. How much did he have after his 2 years? So how do we work that out? So year 0 is 4,500. We are looking for year 1. How much did he get in year 2? Yeah? Pardon? Okay. So 4% per annum. So what do we do? Is it an add or is it a multiply? Times something. So what we times? Compound again, yeah? Compound interest is multiplied by something. Add, yeah. All of these that I've given you are compound, so they're all multiplied. Multiplied by what? I want to do an increase of 4%. So if I tell you the difference, find 4% is times by 0.04. But an increase by 4% is timed by 1.04. Remember? Because increase means find 104%. So we've got to multiply by 1.04. Otherwise, your numbers will go down quite significantly each time, yeah? Oh. Go for it. 4,000. Have you done it straight away to the end there? So I'm going to do it as straight away. I'm going to say it's 4,500 times 1.04 squared. What do you get? I don't even need the middle term. Like that. Bounce. Yeah, easy enough. Easier than the other one we just did. Depreciates. Do you know what the word depreciate means? Yeah, so depreciate means goes down in value. Okay? So the value of a car depreciates. At the end of 2007, it was £5,460. At the end of, so that was 2007. It said work out what it was in 2006. So this is what I want to work out. Now, depreciation. We've got to work out, so multiplying by 0.35 finds 35%. But I don't want to do that. I could do it in this way because there's only one step. What do I multiply to? I want to actually decrease by 35%. How do I do that? Makes sense, but actually that just gives you the same number, but negative. Yeah? It makes sense, but what does multiplying by 1.35 find? 135, so a 35% increase. So dividing, Sienna, would be a great way of going backwards if it was an increased problem. Right, so if I thought the car was increasing in value, what we've just said would work. But it's not an increase, it decreased. So this number is actually going to be higher than that one because the value was increased. Now, here's the thing. We've got to figure out how do we decrease by 35%. Now, here's my tip. If I decrease by 35%, how much is left? So we start with 100%, and we minus 35%, we get 65%. So to decrease by 35, we actually want to find 65%. So we actually, to decrease by 35%, you actually want to multiply by 0.65. So, in our question here, look, from 2006 to 2007, it would have been multiplied by 0.65 because it depreciated by 35%. Now, this is where Sienna's method does work. I want to go backwards. So, what do I do? Divide. So to go backwards, I actually need to divide by 0.65. And what do I get? Exactly.
Yes.
I'm not sure where Luke is because he was in different places. So,
Luke was here, was he?
yeah.
Now, is that all right, guys? Now, I'm going to get you to write something down. You've got space on your sheet, or you want to do this in backwards. Okay, so this is important actually, I'm going to write this in pink. So I'm going to say there's a common mistake. So the common mistake for this question, if this is 2006 and this is 2007, right? If I want to know what that is, and that's 5,460. If we look at that and say, okay, that was minus 35%, does that make sense? Yeah? So that it is part of a mistake, but that bit itself, that way of thinking, there's nothing wrong with that, is there? We are subtracting 35%. All right. So does it make sense then that if I wanted to go back, that we just add 35% back on? Why not? Or adding it back on, yeah? Yeah. So you don't like that. Glad that you don't like it. It's the wrong thing to do, right? Let's just do it though. So Alistair said, let's find 35% of 5,460. So how do we do that? It's 0.35 times 5,460, and then add it on, right? Or we could do, no, actually, yeah. Or we could do a 1.35 again. But let's do this. Let's do 35%. What do we get? 1,000. And then let's do 5,460. Let's add that back on. So add 1,900. What do you get? 7,000. Careful. Something going wrong here. Well, no, the numbers should be. Let me just check something. That's right. Oh, no, probably is right. Times okay. No, it's fine. Actually, why are those numbers different then? So this is the correct answer. This one is wrong. We've said that. But why didn't it work? Yeah, but can we that does it make sense that if I've subtracted 35%, I can just add 35% back on? Does that make sense? So it makes sense to do it. But that's what I'm trying to do, yeah? If I want to know this number here, if I know this number minus 35% is that, if I add it back on, don't I get back to that number? Yeah, it kind of makes sense. So why doesn't it work? Well, this is an important aspect for you to understand. When this number is decreased by 35%, we work out 35% of that number, don't we? And subtract it. Yeah? This number, is it bigger or smaller? Bigger. So, if I work out 35% of this number and subtract it, I will get that. But if I work out 35% of that number, that's a smaller number, right? Will it be the same number that was subtracted then? No. So this amount here is the problem, right? This number is smaller than what was subtracted, okay? So 35% of the question mark is larger, let me rewrite that in one line, right? 35% of the question mark is a bigger number than 35% of 5,460. Does that make sense? So you can't work out 35% of the answer. So that takes us back to this method. Using the sequence method is a much, much better way of doing it. Well, it's the correct way of doing it. All right?
It's
Well, that was ages ago. That was all there. If I decrease by 35%, I start with 100%. If I subtract 35% from it, how much am I left with? 65%. Yeah? So if I want to decrease an amount by 35, I don't think of the 35, I think of, well, if I'm decreasing, I actually want to think, what do I end up with? So when we increase, I don't think about the number that I increased by, I think of what I will end up with. So an increase of 14%, I will end up with 100 plus 14, which is 114%. So if I find 114, it does it for me. Yeah. If I want to decrease by, so that maybe I can write this down in another bit of paper just to confirm for you. Okay. So if we increase compared to decrease, so if I do 14% increase, I will find 114%, yeah? If I decrease, I will find, well, 100, so this was 100 plus 14, this will be 100 minus 14, so I will find 86%. If I do 27%, it will be 100, so an increase is nice and easy, yeah? It would just be find 127%. But a decrease will be 100 minus 27, which will be find 73%. Yeah? If I do an increase of 68%, means I'm going to find 168%. Because it's 100 plus 68. Here it's going to be 100 minus 68, which is find 32%. Now the question is, once I've done that, everything's then the same. How do you find 114? You multiply by 1.14. Multiply by 1.27. Multiply by 0.86. Multiply by.
And obviously it's supposed to be a small number like that, it can't be like 11.
No. Well, no, actually, that's a good question. Let me deal with that. So let's increase by 115%. So if I increase by 115%, I'm going to do 100 plus 115, which is 215%. So find that. What do I multiply by? 2. So So it's going to be more than double. So if your salary goes up by 100%, it doubles. Yeah, make sense? What if it decreases by? It's going to be negative. It's going to be 100 minus 115%, okay? Which is going to be find negative 15%, which is going to be multiplied by negative 0 point, which doesn't really make any sense. So we can't really decrease by more than 100%. We can decrease by 100%. What's your salary if you have a 100% decrease? Nothing, exactly. We can't go below that because it doesn't make any sense. Does that explain that? Okay. So, two things then. So we've done depreciation. So just to remember, that is a mistake. The adding on, subtracting is a mistake. We really want to focus on this one. So because I've done that and kind of maybe confused you, let's do another depreciation one. So let's find another depreciation question. This one. Do you reckon you could do it without me to start with? Have a look. So just go through for the video. Depreciate by 25% means it goes down 25% every time. It means each time we need to find 75%. That is multiplying by 0.75. So because of the way it is, each year it depreciates. So obviously when you buy it is year 0. So it's 1, 2, 3 lots. So you can either do it step by step and write them out, or you can do it power of 3. To you. Okay. Back to let's do, we've got time. Can you do one more, okay, of compound interest? So we start with 154,500 for 2 years at 4% compound interest, work out the value after. Nice and simple. You want to talk me through it? So we're going to multiply by 1.04, good. How much? 167,000? 102.2. Cool. Seems right. You want it to visualize, so year 0 when we invest is 154,500. Year 1, year 2, so that would be times by 1.04, times by 1.04 again, and yeah, you don't need to find the middle value, you just go straight to. So for those of you that prefer to visualize, but yeah, spot on. Okay, shall we set you your homework? Right, so this one is a challenge. It's got something new, so I would do that one second if you could. All right, but the first one I want you to do. So a depreciation one. Right, that one. Let's do this one. Do that one first.